Plan for this webcast is we'll start with a brief look at the most important new feature of C#5. Then I'll demonstrate what's new in LINQPad to support that feature. Then we'll take a tour of what else is new and upcoming in LINQPad. And then finally we'll finish with a Q&A session. Now, the most important new feature of C#5 is asynchrony. Now, I'm not going to cover that in detail because to do that would take the entire session. Instead, what I'm going to look at is why it matters, why you should care. Because right now, you're probably thinking you're using threads and you're using background worker and you're thinking, well, do I really need to learn these new keywords and how do I use them? What is it going to do for me? How is it going to make life easier for me? Now, asynchrony is an aspect of concurrency. And concurrency, if that strikes fear into your heart, it should. It's probably the hardest thing in programming. And the good news is that there's been a lot of work recently on precisely on making that easier. Now, if you look at the previous, what we started out with when it came to the .NET framework, we had threads and we had things like thread pools, signaling constructs, and so on, monitors, locks. And then in Framework 4, they added libraries to make parallel programming easier. Now, with parallel programming, what we're trying to do is take advantage of multi-core processes. We're trying to get all those calls hot. And they gave us two APIs to do that: the task parallel library and plink. Now, this reflects the kind of theme of C# and the CLR, which is that it's a kind of a multi-paradigm language. There's on one hand imperative, on the other hand functional. Now, imperative is a traditional style of programming where you say how you want to do something through control flow statements like while, for each, if else, and variables, local variables whose values change. Functional, you say what you want to do through a series of functional transformations. And then you let the runtime work out how to do it. Now, typically, functional, you're working with lists or sequences. When you use LINQ, you're doing functional programming, non-side affecting operations. plink is an extension of that. Now, the two approaches complement each other nicely. Some things work better functional. plink, some things work better with the imperative approach, task parallel library. Now, both of those things, these are part of the parallel programming that we got in Framework CLR4. Now, what they've been doing since then is they've been addressing the other half or another part of the concurrency problem, which is how do we deal with latency? Issues when you've got an operation which takes a while to run, whether it be compute-bound, making calls hot, or whether it's I/O-bound, like waiting for a web page to download. How do we deal with that? Now, they've given us, just like they did before, the two approaches. They've given us two approaches again, a functional and imperative. The imperative is asynchronous functions in C#5. This is this big new feature of C#, the await and async keywords. Now, the other part, the functional approach to solving that, where you're kind of working with sequences and non-side affecting, is Reactive Framework. It's not actually part of the framework, it's a separate shipment, but you can get it in a few seconds with NuGet. Now, let's have a look at these in a bit more detail. Asynchronous functions, they're designed to work primarily with tasks, whereas reactive extension, the thing that you work with is observables. Now, what is a task? A task manages a concurrent operation. So you can think of a task, it starts and then sometime later it finishes, and it typically yields a result. So you could have a void task with no result, but typically you get a result. Now, an observable is very similar. It starts, and then sometime later it yields a result. But then it can yield another result a bit later, and so on. In other words, an observable is a task that keeps on giving. Another way to look at it is that a task is an asynchronous value, right? A value that manifests in the future, whereas an observable is an asynchronous sequence. Now, it's possible when you're programming any function you write that potentially takes a long time to run, whether it's compute bound or IO bound, you can have it return immediately to the caller and return a task or an observable. And then the caller then can then use that to attach hooks to ensure things happen when data becomes available. Now, if you program in that manner, you're doing asynchronous programming. It's as simple as that. You're using tasks and observables throughout your call graph. And what do we mean by a call graph? Well, you've probably all seen a method like this. I hope you've not written one, but imagine a method that's got 1,000 lines of code in there. And what's the traditional basic way that you would deal with that? How would you make that simple to work with? Well, what you would do is break that down into lots of small methods, right? So you do something like this. Call graph. So method A calls method B, then it calls method C. Method B calls method D, then method E, and so on. Now, the interesting thing about a call graph is that these methods, they need not exist all in the same class. They may exist in different types. And because we have these powerful abstraction capabilities such as polymorphism and interfaces, it's possible that this call graph could not be at all obvious by looking at the code. So let's say, for instance, you call a method on an interface. You may not know what the actual concrete type is that implements that interface. Right? It may even be supplied at runtime through a dependency injection framework. So the important thing about a call graph is that it's a powerful abstraction, and particularly when it runs over lots of classes, but you can't just tell by looking at your code easily or at all what methods are in that call graph. Now, let's suppose that method at the bottom right, G, that method takes a long time to run. That method is long running. Now, what that means is that the method above it, E, is also going to be long running. Well, we're talking normal synchronous code at this point. So method E is going to be long running, and then so is B and so is A. Right? So it goes up the call graph virally, this long running. Now, if you're calling method A from a rich client application such as WPF, Windows Forms, Silverlight, or Metro, what's going to happen? You run that on the UI thread, that long-running method A, and your whole program becomes unresponsive while that runs. Now, we try and avoid that, right? So how do we traditionally solve that problem? The standard approach, I think you're probably doing now, is you're running okay, so we've got an asynchronous call graph now. So instead of having long-running methods going up the call stack, we've got asynchronous methods going up the call stack. So this method G, instead of being long running, what we're going to do is it returns a task or an observable. And this task or observable, that means that method E also must return a task or observable. It travels up the call stack. So we've now gone from having long running methods up there in that branch to having asynchronous methods. What we've gained by doing that is that if we're using C#'s asynchronous functions, then if we call method A from a UI thread in a rich client app, then the entire call graph remains on the UI thread except for the actual method G or the portion of that method G that is compute bound. And if method G is IO bound, the entire thing ends up on the UI thread. This simplifies thread safety significantly. So what we've got now is we've gone from a situation where we've got potential unpredictable thread safety errors to a case where we've got pretty much certainty regarding the thread safety here. It's not impossible to get thread safety errors, but it's much, much simpler to deal with because the only point at which you can be preempted in that call graph is before and after an await statement, which makes it explicit and very, very simple to deal with. This is the first major benefit of switching to the asynchronous model of programming. Now, you've always been able to do this, so why do we need these new keywords in C#5? Why do we need these await async keywords to do it? The answer is that if you look at how this call graph runs, that within the call graph itself, it's sequential. A calls B and then it calls C. It doesn't call B and C in parallel, right? So what it means is if B is asynchronous, remember B is going to return immediately to the caller. So if it calls C, B and C are going to run together. That can't happen because C needs the result of B to do its thing. So we need to tell B, like when you've finished, like take your result and hand it over to C so it can start. Now when you start writing your program like this, it becomes incredibly complicated and difficult to wire together. This is why we don't do asynchronous programming. Managing these continuations becomes a nightmare, especially if they're inside a loop and they rely on local state. Now what the await and async keywords do is they allow us to write asynchronous code which looks almost exactly like synchronous code. You simply write it as though it was synchronous, and you sprinkle the await and async keywords in there. The compiler does all of the magic, all the continuations, hooks it all up for you. That is the beauty. If you've ever used iterators, you've used yield return, very, very similar thing. You can, with yield return, you can yield an element into a sequence effortlessly with that, without having to worry about all of the plumbing. The same thing with asynchronous functions. Now, that applies to rich client apps, right, for WPF, Windows Forms, Metro, and so on. But what about with other kinds, like web apps and other kinds of apps? Are there any other benefits to this model? And there are two others, and one very significant benefit. And one of them is, let's suppose now that it's not just method G at the bottom that's long running, it's also method C further up. Imagine those are both long running. Now we're going to asynchronize them all, so we end up with that. But let's also imagine now that B and C can actually proceed independently. Right? C doesn't need the result of B. So why not run B and C in parallel? That would make good sense, right? Now, doing this is traditionally quite an awkward thing to do. Whenever you start to introduce parallelism into your call stack, particularly if it's unstructured parallelism, then it becomes really complicated. You need locks, signaling constructs, semaphores, and so on. And this is another real source of pain and errors and unpredictable bugs and multi-threading. Now, the really nice thing about asynchronous programming is if these methods are asynchronous, if you want to run them in parallel, you just run one after the other, and they will implicitly run in parallel. That's given. So the question is, how do you then, when they're finished, how do you kind of parlay up and get their results and then give it back to A? What you do is there's a method called here task.whenAll. So it returns a task that signals when all the tasks that you give it signal. This is called a task combinator. It combines tasks. You give it two or more tasks, and it gives you another one that signals when something happens to those other tasks. That's a very simple task combinator, but there are more complex ones that you can write. And I've given some examples in C#5 in a nutshell of some very cool combinators that you can write. There are also more in the white paper for asynchrony in C#5. And what is really good about task combinators is that they're actually quite complex to write. They can be tricky to write, and you can end up with subtle multi-threading bugs if you're not careful. This is a good thing. Why? Because it gets all of this complicated multi-threading signaling logic isolated into these small little methods that have got no business logic in them, that they can be unit tested, they can be audited, they can be reused. So you're getting this nasty multi-threaded logic out of your business logic, and you're putting them into reusable methods, task combinators that can solve these problems. And the typical kind of problems you'll solve is dealing with things such as timeouts, cancellations, and exceptions, and so on, and unstructured parallelism. Task combinators are a really nice way to take that complexity that traditionally causes errors and filter it out and put it into something that's testable. The other nice thing about the combinators is it changes the kind of information flow somewhat. So what tends to happen is the information flows through the parameters that you call the asynchronous functions with and back through the continuation, through the return values, effectively, which is what they are. And that reduces the need for shared state. You won't even realize you're doing it, but you have less shared state when you take this approach. That also makes it simpler. So That's how we combine tasks. What about tasks that keep on giving, the observables? How do we combine observables? Well, Reactive Framework has a whole library of functions for doing that. In particular, it implements all of the standard query operators. So a LINQ query combines observables. And then other nice thing about all of those standard query operators and all of those special extra ones they're provided is, again, they're doing all of this complex concurrency multi-threaded stuff for you, so you don't have to. There is a learning curve with Reactive Framework. But the good thing is that when you start learning this, how these things work, it means you don't have to put this complicated stuff, logic, concurrency logic, into your program. You're relying on something that's been thoroughly tested. So those are the two major benefits of going with an asynchronous model. And there's a third one as well, which is in server applications, certain kinds of server applications, you get a quite improved thread efficiency because there is no blocking. Like when you're working asynchronously, you don't block threads. You always exit with a callback. So that can be sometimes very useful as well. So if you want more information, I'm not going to give too much details as to actually how to use Async because it's kind of another presentation. But I've given one. If you go to my website, albahari.com, I've given a level 4 TechEd presentation. It's on Channel 9. That was last year on asynchrony. There's more detail in C#5 in a nutshell. And there's also a library on LINQPad, a sample library you can download with a tutorial on how to use async functions. So let's go to screen share, and we'll set this up. Okay, what I'm going to look at now is what's happened to LINQPad in the last year or so to help you play with concurrency and asynchronous functions, because LINQPad traditionally was a tool for experimenting with queries, but it's since evolved into a code scratchpad, a programmer's playground. And originally it didn't handle multi-threaded scenarios very well, but it does now. And start with something really basic. This will start up a thread. Sleep for 2 seconds and then say hello from a worker thread. So if we run that now, and if you watch the status bar at the bottom, you notice it says query successful, finished. And then 2 seconds later, hello from a worker thread. So you're allowed to have worker threads popping in. The other thing it does quite well now is that if a worker thread throws an exception, so if this throws a null reference exception, it won't take out LINQPad. What will happen instead is it will highlight that error in exactly the right place and tell you even where that error has come from. It's much easier to work with. Now, an interesting feature of LINQPad is that it creates an application domain per query, and by default it uses the same domain each time you run your query. So if you say start up a thread and have a loop that just keeps writing hello from a thread, run that one now. So every second it's going to say hello from thread 34. Now that query is finished, right? But the background thread is still emitting data. Now what happens if I run that again is it's going to be hello thread from thread 78. But thread 34 is still going, right? So we can run that again. Now we've got 3 of them going. Now, if you want to stop all of this craziness, there's actually a little message on the bottom right there, Control-Shift-F5 to cancel all threads, and it's on the query menu as well. So that kills the app domain. You can also, if you don't want that behavior, you can go to Preferences, and in Advanced, you can tell it to always use fresh application domain. So whenever you hit F5, it will discard the last domain we're creating. Now, that's standard multi-threading stuff. So what about asynchronous functions? How does LINQPad handle that? It recognizes the await and async keywords, and it works just like it does in Visual Studio. There are 3 ways to use it. You can use Windows 8, download Windows 8. You can download Framework 4.5, the release candidate or beta, or you can download the Async CDP, which patches VS 2010 and the C# compiler. That's quite a cool way to work if you want to use Async and your customers are still on Framework 4, because it comes with an implicit go live license, and all you need to do is distribute an extra DLL. You don't need to patch your customer CLR. So LINQPad will work with all of those. What this example here does, we'll run that one, is it downloads a web page and dumps it out, and does this asynchronously, so it does it without blocking the thread. If you look carefully at the status bar and I run that, when it says query continuing asynchronously as it's running. So LINQPad knows it's going asynchronously. To give another example, we're going to write, demonstrates a responsive user interface. So what I've done now is created a new button. This is a WPF button. Put the content as download, and on the click event, I've disabled the button, and now I'm downloading a large zip file, which will take a number of seconds, and I'm awaiting it. So what this means is that as soon as it hits that await statement, it's going to exit from that event handler so the UI can remain responsive. And then when it finishes, it jumps back in here on the same thread, on the UI thread, and updates the button's content. And then when it's finished all of that, it re-enables the button. Now, this is another change in LINQPad recently, a few months ago, is that any WPF element or Windows Forms control, if you want to display it in LINQPad, you just dump it, and it will display it. It will then create a message loop for those controls and render them. So this is a much, much easier way than having to create a whole new application in Visual Studio. So I run that now. You can see we've now got a download button and a text box. Now, the reason I've also dumping out a text box is so that we can just test to make sure this is responsive, that the message loop is responsive. So I can type into here, hit download, and now I can continue typing. The message loop's still working while it's downloading that large zip file. Eventually, it should come up with an answer and tell us how many bytes it's downloaded. Here we are, 1.8 megs. Now, so that's the story with Async. Now, if you want to see in much more detail how that works, go to Samples, and what you'll notice at the bottom of here is there's a Download More Samples link. If you click that, there's a sample library which gives you a complete tutorial of async functions with dozens of examples on how to do that. So if you download that, you'll get this one here, this asynchronous functions in C#, and it will give you numerous examples on how to use async and await. Now, what about Reactive Framework? How does LINQPad work with RX? Let's close all of those. Let's start from scratch. So I want to do a reactive query in LINQPad. What we do is we need to add a reference to we should download the libraries for RX, add a reference to it. So we go to F4, which is the query properties. And the easiest way to get it, if you've got a LINQPad premium license, is to hit the NuGet button. Everything is on NuGet. It's so cool. So if we want reactive extensions, we just click RX, and it'll search for it. And I've already downloaded it in another query, so it's actually in our local package cache here. So I can just click Add to Query on the reactive extensions here. Here we are. And it remembers the namespaces we added last time, so I don't even need to add anything else. So that's it. So I can just click OK on that. That's it, and now we can start doing reactive. So observable is the class it's equivalent of enumerable for LINQ. And so I can say, for instance, I want an interval. That gives us a sequence that counts from 0 upwards, but instead of doing it immediately, like with enumerable.range, it waits a time period between each value. So I'm going to put observable, and I want 0.5 seconds. 0.5 seconds. And I want to take the first 20 items. So this gives us an iObservable, which is this task that keeps on giving. So then we could subscribe to that in order to dump out the results. But you don't have to with LINQPad. You can dump an observable. You can dump anything with LINQPad. So what it does is it subscribes automatically and shows you the output. So this, again, makes it a lot easier to start getting productive in terms of getting familiar with RX. So this gives us the first 20 numbers. Now, where did that's an extension method. Where did that come from? That's not part of RX. I wrote that because I don't like using that time span dot from. I think if you look at the help here, it expects a time span in there, and I don't like having to type do verbose time span dot from. milliseconds. So if you go to My Extensions, this is another recent feature in LINQPad. You can create your own extension methods, or you can create any types you want, and anything that you put in these extensions is available to every query. So I've just created an extension method that returns a time span from a double. Now, one of the interesting things is about the way it works is if you set the language to expression, LINQPad will just automatically dump whatever that expression evaluates to. But if I set it to statements, then I can just put the dump in there, and this will give us exactly the same. This is now a statement. This will do exactly the same thing we had before. Now, I can also put in a heading there, like 1, and now it will prefix each of those items with 1. What happens if I copy and paste that and put 2 in there? Is it going to dump all of the first 20 elements of 1 and then dump all of the elements of 2? The answer, it doesn't, because it knows the theme of reactive extensions is asynchrony. And so what it will do is those calls to dump are actually non-blocking when you're dumping observables. So you'll actually see them intermixed. You'll actually see them. So the query will continue, but it's actually giving it to you as they're arriving. Now, if we change this to 200, let's say, and we get that down to maybe 0.1 seconds, 0.15 seconds, it's going to get kind of hard to keep track of what's going on because stuff comes out so quickly. So there is another way you can do this. What you can do is there's another extension method called dump live for observables. And what this does is instead of just doing like a console.write line, it actually shows you just the latest value and updates it in real time. So let's run that now, and you'll see here we are, the observables being rendered in real time. We can make that bigger. Now, how does that work internally? How does dump live work? It creates a WPF content presenter, and it dumps it. Right now, if you're curious, you can go to Help and reflect on current type member. If you've got .NET Reflector installed, it will reflect it, and it will reflect itself. LINQPad most of it is not obfuscated, so you can look inside there and see how it works. So sometimes reflect is a bit flaky in how it responds to the command. So we'll try that again. Here we are. So that's the disassembly of the dump live method. So we can go into that and have a look at it. And it is actually quite simple, although you find, as with almost any code, 90% of the complexity is just to deal with the really esoteric exceptions, corner cases. Essentially, it's fairly simple. What it's doing is it's creating a WPF content presenter and just putting that stuff in there and subscribing to it. So what we're doing here is the observable.interval returns an observable of long. So it's a long integer that it keeps pulsing out. But one of the things that are quite cool things you can do with LINQPad and Reactive is you don't necessarily have to give it a long. You can give it any WPF element, and it will render that. Right, because of the way that the dump live rendering works. So this gives you a nice way to visualize things. So an example I've got here is I've got a for loop from 1 to 10, and what I've got is I'm using that interval function. I'm taking 101 elements, and I'm now doing a projection. So I'm mapping that long into a WPF progress bar whose value is the value I want to show. So when we do that, what you'll notice is you can actually see this animating in real time. So instead of just projecting a simple value, we're projecting a WPF element, and it renders that in real time. Now, I'll show you a couple of other examples. One thing I should point out here, though, is you see that dispatcher scheduler. When you call interval on there, it's going to have to send some kind of pump to get the concurrency happening. And by default, it uses a thread pool. But you can tell it to use any other mechanism you want through the scheduler, which is a reactive framework concept. And if we tell it to use the ordinary default scheduler, it's going to cause a problem. Just in LINQPad, it's exactly the same as it will in any other program, is if you create 10 WPF objects, each on a different thread, and try and render them together, it's not going to work. So you've got to get them all on the dispatcher thread. So that's why we tell it to use a dispatcher scheduler.instance. So it fires that all on the dispatcher thread. Now, a couple of other examples. Eric Meyer wrote these for LINQPad, and I don't fully understand them, so they're pretty cool, but it shows you what you can do with LINQPad. One of them is, this is a reactive mouse trails. So there's not a lot of code here. It's actually quite simple, but it's very clever how it works. If you look at what's going on, again, we're using, this one uses WPF. We're creating labels, and then we're creating a canvas, and we're adding them to all these labels to the canvas. Each label is a letter of the alphabet. And let's watch what happens when we run that. You can now, it just follows the mouse cursor, and how well that renders over the net, but it follows the cursor around the screen. And again, we're just creating a WPF canvas, and we're calling dump on it. Here's another example. RxPad. This uses Windows Forms. So again, this is a fairly simple Rx program. It's just one page of code with some helper methods. And when we run that, it gives us a pad that we can draw on. Okay. This works because Reactive Framework also, it's not just a case of it being asynchronous sequences, it also acts as an alternative to events. So it does the same job that events, CLR events do. In that, and if you think about an event, it just pulses out information periodically, same way as an observable. Follows the same pattern. Events, though, are not programmable. You can't kind of do any cool things with them. But with observables, you can. You can do link queries over observables. So what this does is it converts the events, the Windows Forms events, into observables, and then you can do these cool queries to write programs such as that. Now, I said that dump eats anything, and that there's one other thing as well I want to show you that it eats. And I don't know if any of you have come across Dataflow or used it. Dataflow is another thing that they provided in Framework 4.5 and also in the Async CGP. And it's yet something else in your toolbox to deal with difficult multi-threaded scenarios. It's kind of related to the actor-agent model, but it's not exactly that. It uses anything that might benefit from a producer-consumer queue is quite possibly will benefit from Dataflow. The idea is you create blocks. These things have buffers in them. They can transform items, or they can do things with items. They can buffer items. They can broadcast items. You create these networks of blocks, and then you can set a degree of parallelism, and you can bound the blocks so the queues build up on the input and output side. This is a really clever way to solve certain kinds of parallel programming problems. I've also given a demo on this. I've given a presentation for Channel 9, also TechEd presentation on Channel 9, and it's also on my website. There's a link to it, The Future of Parallel Programming. So I've given a demo on how Dataflow works, and it's worth looking at that because it is a kind of niche scenario of problems, but if you ever do run into a problem that can be solved with Dataflow, if you don't know about it, you will reinvent the wheel, and this certainly makes it easier. Now, how this relates to LINQPad is that any of these blocks that you create, these Dataflow blocks, you can dump, and it gives you a live visualization of what's happening. So in this case, you can see what's happening is we've created two blocks, and the blue things, that's the input buffer. The red thing shows what it's processing, and the green is on the output side. So you can actually see what's going on in real time with your Dataflow blocks. Okay, so a few more things I want to show you that have gone on recently in LINQPad. One is that we've got now results to data grids as well as to rich text. So I can go to a database, purchases.take100, and if I want to display that in a grid, I can either do it through this extensor here, or I can just change it to the grid there and run it again, or I can use one of these snippets here, which they all go into grids. Now, grids are kind of different to the benefit of grids is that there's no limit to the number of rows it will display other than the amount of memory you've got. The other advantage is it's good when you've got lots and lots of columns because of the scrolling. You can freeze columns as well with the right-click menu. These things as well, you can sort on these. You can click the header to sort, and there's incremental searching on these. You just start typing, and it will find the element in there. There's also export to Excel and CSV and HTML in here. But one of the features I like most is that all of the associations are clickable. So you can click this and it brings up that customer, brings up their purchases, and then brings up their purchase items. And what it's doing these queries as you click it. It's not rendering it in advance. Now this is a difference. When you do a query with in results to text mode, to rich text, it basically gets a snapshot. When you do a dump to text, it gets a snapshot of how it was at that time. Whereas when you're using results to grid mode, and we don't just have to use databases, we can also do it with any type. So I could put, for instance, type of int in there. We can dump that one out, run that, and now this now is showing in a grid, and what it means is that I can go into any one of these, and there's no limit to how much I can keep clicking in there because it's working it out, it's doing this at runtime. So sometimes it's useful to actually know what there really is at runtime. Sometimes it's more useful to have a snapshot as it was when you call dump. So that's what they both kind of complement each other. Now, one thing I've done recently, which is not yet in any build to enhance this, is if you do get a dump to a grid from a link to SQL source, you can hit edit in there, and now it will open that up for editing. So I can now put bikes instead of bike, and it will now write that back to the database. And if you go to the SQL tab, you can actually see exactly what it's done. And this is all copy and pastable, so you can replay your changes if you want. So you can go back here now, and you can add new items as well, so we can put another one in there. And now that's saved that new row in there. And we can then go to the customer and the purchase items, and we can add new purchase items as well. And it will automatically fix up the foreign key associations and so on. So that's coming soon to a beta near you. Now, I'll go through a few more tricks and tips that I'd like to demonstrate. One of them, this is a new method, which is util.display web page. And what this does, it just shows a web page in the output window. But there is a little trick you can do with this, which is you can actually put in here a file path, and now it will render that as well. And that can be kind of useful sometimes when you want to browse a file system, and you can go to you can go forwards and backwards. You can right-click and how you get access to the context menu. But what I particularly like is if you browse a folder, and find one, a really large folder such as downloads or temp, then it comes up, for whatever reason, it comes up straight away. You don't get that green progress bar of death that you sometimes get in Win 7. Now, another useful tip is the util.command. There's actually a shortcut for that. If you go to the edit menu, here, Control-Shift-X actually pastes that straight in. So if you want to run something like dir, you can just type util.command, highlight that. That brings up the directory. But the example I've got here is a bit cooler because it actually returns a enumerable of string. So what you can do is then do a LINQ query. So I'm calling ipconfig and getting everything that contains DHCP in there. Now you can use LINQPad for scripting, which is what I do. I use it, for instance, for doing a build and then uploading the build to Azure. But what I found is when you're uploading things to Azure FTP or whatever, you need passwords. And I hate storing passwords in plain text in scripts. To me, it's a security issue. So there is a feature called util.getPassword. For instance, if you're sending email through Amazon SES, you can put util.getPassword, give it a name like Amazon SES key. When you run that, it'll ask you what the password is. You type something in there, And then if you click Save Password, it'll save it now in secure storage using the Windows DP API cryptography. So that's the password we typed in. But if I run that again now, it saved it, so it won't ask for it again. If I want to change it, we go to Password Manager. And now we can, there it is, I'm using an STS key, and we can change the password or delete it or whatever. So this is good. Now, the other option, the other way around this, which is what I used to do, is to, in fact, we can do it from LINQPad, right? We can take take a file in here. If you want to encrypt that, you can go to Properties and choose Advanced and use that one there. If you've got the right version of Windows, it will let you encrypt that file using Windows. The problem with doing that is that how do you do your backups? If you back up, it'll either won't back up at all or it'll back up unencrypted. So the advantage of doing it this way is that your script itself is unencrypted and backs up correctly, but your password is secure. Another tip is util.progress. This is a value, an integer, you can set to control the progress bar and the status bar. So if you look in the status bar now, you can see the executing, that progress bar is moving across. We're controlling it just with that util.progress. And that's also useful when you're doing uploading large files. You want to ensure that it hasn't died. Another one is util.raw HTML, because the output from the results is just HTML by default. So if I right-click, I can hit View Source, and that rich text output is just HTML. So there's no reason why you can't inject your own HTML into there. And I've just created one called a heading. Now, when you're calling HTML, raw HTML, you can just put a string in there to say what the HTML is, or else you can put an X element. The advantage of an X element is you can put symbols in there, you don't have to escape them. So that, for instance, puts a heading 1, put foo in there with brackets. We don't have to escape those brackets. The other way, if you want to do fancy formatting, of course, is to go into WPF and just dump a WPF text box that I've done here. So that gives us the same result. We can dump. In fact, you can use this to create visualizers. You can create an extension method in My Extensions, which could be called dump or something, and it takes a specific type, and it just dumps a WPF element that renders that type. So there's a lot of possibilities for using WPF, and because WPF is quite good with a large number of objects, we can call dump on that and turn it into a statement, and then just repeat that a few times or 100 times, and it just stacks them on top of each other, and there's not a perfect for doing that. It works quite well. So those are some tricks and tips I have, and there's one other thing before we open up the questions, which is I wanted to discuss one of the things that I'm working on at the moment, which is one of the requests. It's been, if we bring up the user voice, is the requests. LINQPad feature suggestions. Some of the top requests are for command line interface, automation interface, reference and execute LINQ files, include a CS in, and all of these have got something in common, which is give an option to generate an executable. Now, this is something that I most likely will be doing next, which is to allow scripts to compile to executables, because that will do give you a lot of the goodness that you would get from having a command line option. The advantage of generating an exe over a command line option in LINQPad is that it would host the query natively rather than in the LINQPad process. So that's probably how I would go about doing these other things. It also means that with an executable, you can it would allow you to reference other queries simply by referencing the executable that you're generating. So it would take care of a number of these other things as well. I'm certainly interested in feedback that people have got for doing that, and also the scenarios for wanting a command line interface as well, because I've noticed some people want, for instance, to use LINQPad on a build server to do their build scripts, because C# is actually a really good scripting language. It's very powerful, but most of all, you know it. you're really familiar with C#. So you could be so much more productive in that than just about anything else. So it's a great language to do your scripting in. And if you want to do it to do things like a build and you want to do it on a server, then it is really useful to have that kind of option like a command line interface. So there may be other ways of doing that as well, which I'm interested in hearing about. So what I'll do now is we've got about 10 minutes or so to go. So I'll open it up to questions. So let's go. I'll stop screen sharing for now.
Great. And Joe, fantastic webcast. We do have several questions that have come in, as you can imagine. Are you able to see them in the Q&A tab?
Okay, let's have a look. Okay, the first one we've got here is a use case for this. If I set a breakpoint in my app at a point where the collection is created, is it possible the collection that is present in the app and start querying it in LINQPad? Okay, now regarding now I think what the question is related to setting a breakpoint in Visual Studio, and then somehow getting LINQPad to reach into the process that Visual Studio has got access to in the debugger and then query that. That's not on the agenda. I don't imagine that will be easy at all, if even possible, to do that. On the other hand, it might be an option to have LINQPad scripts debuggable by creating a shim and letting Visual Studio get into that, and that is something I'm considering. With a compile to executable, what it may do is create a VS proj file and then run MS Build on it, which means that you can bring that up in VS and debug it through there. But in terms of allowing LINQPad to get into the Visual Studio process somehow, it would actually need to, I think, implement all of the debug interfaces, and that's a pretty major thing to do. In fact, I don't think it can even be done as a standalone executable. It'd be fairly major. It's probably not going to happen. Now, you've got disposable.dispose that needs to be called. Okay, if this question is asking about releasing resources for your own UI base. Okay, so I have been a bit lazy about disposing things in LINQPad, and in a scripting environment, you can afford to be a bit lazy. It's not quite the same as like a I guess a production application. So yeah, you can rely more on finalizers, and you can just leave things, because in LINQPad, if you ever want to clean up, you can just use that shortcut to purge the application domain, and that will give you a clean sheet. So there are some things that don't need disposing, but I think that there might have been one or two examples that did. I think that the Windows Forms elements, they should be disposed, although what you'll find is that because LINQPad hosts it in a window, or effectively it's a form, when that form's disposed, then anything on there is going to be disposed too. So it's probably not going to be too much of an issue. Now this one in a call graph, when a method is asynchronous, is there any additional code that needs to be added to make sure an update occurs within a process's primary UI thread? If there is any additional release or cleanup code such as calling. Okay, now the way this works, the way asynchronous functions work, is that if you await a task, then the continuation will honor the synchronization by default, because the way the compiler creates the code for the await statements, it's kind of like it does a for each statement. It's a very simple mechanical translation. So an await will translate to something like it will get the awaiter object on the task and then call the onCompleted method. Now that onCompleted method comes from the CLR, from the task class. And what that does by default is it captures whatever synchronization context is there, and it will then post the continuation back to the context. So that's why you end up back on the UI thread by default. If you don't want to be on the UI thread, there's a configure await option, extension method you can call that can tell it not to do that. Or you can call task.run, right? That's equivalent to task.factory.startNew. What that does is that'll get it again off the UI thread. have you considered adding the ability to LINQPad whereby a user can enter a T-SQL statement and LINQPad converts it to LINQ? Now, I've actually, someone suggested that in user voice, and I've declined that one, and I've given an explanation as to why. The difficulty with converting SQL into LINQ is that it's essentially a lossy process. It's like writing something in like an early version of Visual Basic and then having a program convert it to C#5. It's going to give you an example of how not to write C#5 code. Right, because C#5 is so much more powerful than an early version of Visual Basic that you're going to end up with things like gotos in there, and you're actually not going to get the benefit of C# at all. You might even end up with C# code that's worse than the old VB code you had before. The same thing happens with SQL. I've seen this time and time again. People write this large, complicated, convoluted SQL statement, which is the best you can do in SQL. And then they say, how do I do that in LINQ? And they transliterate it. They literally take that ugly SQL statement and they write an ugly LINQ statement that looks exactly the same. And they say, well, there's no benefit in LINQ. Well, there isn't if you're going to use it like that. And LINQ is a much higher level language. I've seen statements 10 lines long in SQL. It can be sometimes reduced to 3 lines in LINQ. You need to think at a higher level. Don't think, well, how do I do that SQL query in LINQ? What you need to think is, what am I trying to achieve with that SQL query? And then how do I achieve that in LINQ? One of the biggest things is that with SQL, you're getting flat data sets back. Now, this is why are you getting flat results? That's because that's what SQL does. Now, often, in most cases, it can be more useful to have shaped data, hierarchical data, custom with their orders, or purchases and the salesperson. Now, you can get that shaped data back in a LINQ query exactly how you want it. So you can write the queries like that to begin with. Now, that looks nothing like a SQL query. It's much more powerful getting shaped data back. And using the association properties as well, because you get association properties based on all of the foreign key constraints. And what that means is you almost never have to join. If you're writing a LINQ query that hits a database, you should almost never have to join unless you're doing some kind of ad hoc association. So when you get rid of all of the joining, it's amazing how simple things get and how much easier it is. When you read out a LINQ query, it's so much easier to know what your intent is and what you're trying to do than when you read a SQL query which is so diluted by all of the mechanics of actually doing the join. It's very hard to say what it's actually trying to achieve. So rather than trying to convert your SQL to LINQ, go back. Stop thinking in SQL, go back to your requirements and start thinking in LINQ on how to solve that first principles in LINQ. Missed a remark about how WPF changed element behavior to work with. Okay, I'm not quite sure I understand that question about how WPF changed element behavior to work with sync. I think it could be related to when you're dumping WPF elements. If you need to be dumping them on the same thread in order for LINQPad to render those, because it's going to create a single message loop per window. So that's exactly like you would do in Visual Studio. If you're using a reactive framework or you're using anything that can generate events or code that can fire on different thread, if you want to do something to the UI, whether that's creating elements or interacting with it, you're going to have to somehow marshal back to the UI thread. Now, the thing about reactive framework is it is quite nice in that you've got the concept of a scheduler. So a lot of these time-based methods let you specify a scheduler. So if you say dispatcherscheduler.current, that will say, look, use the WPF message loop and use that to generate the events. It is actually quite a nice way of doing it. If you're using tasks, then it tends to be that when you await, if you came in on the UI thread, then you'll go back on the UI thread. So it works quite well with that as well. Okay, someone's asking if LINQPad will ever be themable. At the moment, what it does, it just honors the Windows, whatever Windows theme it is. I've not had, no one has requested that, so it's not really been a priority. And it does honor dark themes though, so you can, if you've got your Windows set up for dark themes, it will honor that, and you can also tell it to make the editor dark if you want. Will there be a .NET 4.5 version? I have problems when trying to access geographical info with Entity Framework 5RC. Okay, now regarding the 4.5, yeah, it already is friendly with .NET 4.5. But in terms of geographical info with EF5, I've not looked at that. It will run with EF5, but if there's special issues, then send me an email if there's some special issues with geographical types in there. Will we get some VS tools like go-to definition and refactoring? I think almost certainly we will when probably in the next year or so. What's going to happen is the next version of C# in the pipeline, and if you haven't heard of it, it's they're providing now a compiler as a service. And what that means is that it's going to make these things practical and economical to write these kind of refactoring. So they're providing all of the necessary parsers, lexers, and binders. At the moment, I have to use third-party libraries and do a lot of work myself. So when that comes out, it means that I can do things such as auto-completion for VB and improve on refactoring and formatting and so on. Control K as well. But that's another thing that will probably come with that, because at the moment that's not in the libraries that I have. Is it possible to run LINQPad on a mono? No, it's not. There are too many dependencies on Win32 and including the libraries that I'm using, and there's also some WPF dependencies as well. Again, if the demand was enough, it might be possible to somehow deal with that, but there's relatively low demand, and it would be a very expensive thing to create and maintain. Any efforts made towards adding autocomplete to VB.NET? Roslyn has moved to CP. Yes, there will be, definitely. Great. Well, I think that's all the questions I've got here. I'll do a refresh in case there's any more.
Oh, let's see. A couple more are just coming in. Let me put them in there for you real quick.
Any interest in adding a web store for user-shared samples, community repository, integrating them directly into the samples pane? That's a very good idea. A number of people have suggested that. It's more thinking about how best to do that, but that's definitely a good idea, having some kind of community sharing for samples or extensions. Any efforts? That one's already done. Is there another one in inbox? Any Iron Ruby? Iron Ruby, Iron Python support. Again, it's creeping its way up in that list, so that's quite likely to happen. I don't think it'd be too difficult to do either. Will LINQPad ever be pluggable other than data contexts? I'd need to know what you'd actually want to plug in. Obviously, you can plug in extension methods and types, and you can also plug in DLLs. There's a plugins folder, and any DLL that goes in there is automatically referenced by every query, so you can get access programmatically to anything you want. Now, I can imagine there'd be other ways as well that you might want to extend it, but you probably want to make a more specific suggestion, and then I can look at that. Is it possible to produce artifacts on LINQPad that is not an XC, but possible to load and execute through Reflection or some IOC plugin add-in framework? I've not thought about that. I'd have to give some thought to that. It's not at the moment possible. Will the samples from this presentation be available for download? Yes, I can make them available, certainly. It's probably tomorrow now because it's quite late here. I live in Perth in Australia, so it's about midnight here now.
Great, Joe. I'm not seeing any additional questions come in, so I'll let folks know. Folks, you can visit Joe's website, albahari.com. It's right there on the screen in front of you, the address, to follow up with Joe, maybe additional questions, or if he puts up his samples, maybe there'll be a link there for it, Joe?
Sure, yes, I'll stick it on the website tomorrow, most likely.
Perfect. And with that, we're going to say a very big thank you to you, Joe, for an outstanding webcast presentation. We have so many comments from the attendees today. They just love what they saw. They're just in awe, and they're really excited about LINQPad. People that attended today, we thank you for attending the event and hope you benefited from it. Again, we thank you so much, Joe. Thank you, everyone. This will conclude our webcast.